morning. Thanks for coming out early on a Sunday morning to this workshop. We very much appreciate you all making the effort to attend this morning. I'm going to talk on a variety of different topics. I have a lot of slides. I have been told I may have too many slides, but they will be available for everybody. And I guess my presentation will also be on YouTube, so you can watch it at your leisure. I'm going to be talking about the OGC Open Standards Policy and business value, and try to tie it into the benefits to geospatial stakeholders in Korea. And we already went through who I am and what do I do. I should add that at the OGC, our staff is relatively small. We have, I believe, 21 or 22 employees to work with 470 member organizations who work on different standards activities. My responsibility is primarily in the area of facilitating the standards development process in the OGC. And I'm also the chair of the OGC Architecture Board and of the Technical Committee and of the OGC Planning Committee. So I wear many hats, and that's true for every individual that works in the OGC. We all have many different responsibilities. The objectives for my part of the workshop this morning is to talk about some of the business drivers for open standards, what is an open standard, how you can actually enhance innovation and research and development and collaboration through the use of standards. We have a discussion of the key OGC standards, and we'll get more details on those from other speakers during the rest of the workshop. We'll look at the value of actually participating in standards development. I know a number of individuals here from the Korean community are very actively engaged in the development of OGC standards, which we very much appreciate. Talk a little bit about specific use cases and examples of the use of the OGC standards around the world. Some opening observations. This is what most people think standards development is like: boring. Put you all to sleep. So if I look out this morning and you all have your heads on your desks, I know I'm not doing a very poor job. And you really just want to flee and get out of the room as quickly as possible as you're working on standards. And it's really boring. But actually that's not the case. And as you'll see in the work of the OGC, we get into so many different interesting aspects of the use of geospatial data, content and services. It's a really exciting, intellectually challenging, creative environment that we work in. This is an example of the cost of not having interoperability, not having standards. In the United States in 2002, our economy lost $16 billion because there was not adequate sharing of data in the construction industry. So when you put in a building, you've got this whole life cycle. It's very difficult to share data through the life cycle of a building, from conception to maintenance. And that cost our U.S. economy is $16 billion in 2002, so it's more now. And if you extrapolate that to the global basis, it's a very, very large number. And that's just for one industry. At the same time, we're faced with global issues that require global collaboration. And the only way you can have global collaboration is to have some sort of mechanism for sharing information, ideas, and knowledge. And that comes back to the development and use of standards. This is how much water there is in the entire Earth in relation to the Earth. That little tiny bubble up there is all the water we have on Earth. It's a limited resource. That's how much air we have on Earth. Again, it's a limited resource. And all the issues and information sharing related to research and how we can better utilize these resources, how we can conserve these resources, comes down to the ability to have global collaborations. And in the OGC, we actually have working groups focused on water and focused on meteorology and oceans. When there are issues of disasters, when a disaster happens, you really need the right data at the right time, at the right location, to the right people. And that's a real problem, and that's where standards again come in. And then we have issues of water, issues of drought. Where I live in Colorado, we had an incredibly severe drought for the last year and a half. To the extent that the price of commodities has gone very, very high. This last one here, obviously, is transportation. The whole concept of infrastructure gets back to my comment about construction. and the cost of not being able to share information can be better planning, better construction, better maintenance of our infrastructure. In Germany, the Germans have understood it for a very long time, the value of standards, and it's ingrained in their business culture and in their government culture that standards create incredible value to the German economy. And what they have discovered is that standards promote worldwide trade, encourage rationalization, quality assurance, and environmental protection, as well as improving security and communication. Standards have a greater effect on economic growth than do patents or licenses. Apple should learn this. There are huge economic benefits to standardization. In 2010, standards enhanced the German economy to the tune of 7 billion euros. So they had a much more vigorous economy due to the fact that they have a commitment to the use of international standards. And it's the end of the day, as we all know as specialists in the geospatial technologies field, everything we do happens somewhere and somewhen. Everything. I can't think of any human activity that's not impacted by location, or where location isn't part of your decision process. And just to summarize the beginning of my talk, we're looking at global challenges across multiple domains. Not just one domain, but many, many domains, and I have examples later in my presentation. As an example, these are just some of the examples of the different domains that OGC standards are used in right now for deployed applications, operational applications. So what is the OGC mission? Let's talk a little bit about the OGC. We were founded in 1994. John Herring and I were just talking about when was really the first meeting of the OGC. We think it was in March of 1994 in Berkeley, California, where Ken Gardell's brought a number of individuals together and facilitated a meeting on the concept of open geospatial data. The OGC started because back in the early 90s, there was no way to easily share geospatial data. If you had two GIS systems from two different vendors and you wanted to share their data, it was incredibly difficult because they both at that time, everybody had proprietary data structures, they had proprietary exchange formats, they had different data models, different vocabularies, different semantics. So at any time you tried to share data, you ran into all kinds of problems. It was very cost intensive and very labor intensive. So the vision, the initial vision that David Schell and Ken Gardell's and a few others had back in the mid-90s was to develop an environment where people could come together and talk about how to share data. And that's how at that time it was called the OpenGIS Consortium was founded. And for the first 3 years or so, we spent most of our time talking about very abstract things, like what's a point? What's a feature? What's a coordinate reference system? What's a polygon? What's a line? There was no vocabulary in the mid-1990s to talk about how to share GIS content, geospatial data. So we spent a long time just getting together an agreement on a vocabulary and models for how you can actually share data. Our first standard came out in 1997, and it's called Simple Features.
99.
Is it 99?
That was 99.
The Web Map Service is also 99. Anyway, our earliest one was Simple Features, and that's a tightly coupled API for querying and accessing geospatial data from a database. And actually, that OGC standard, Simple Features, is implemented in every single commercial database, as far as I know, and every open source database. So it's a very widely implemented OGC interface. We currently have close to 470 member organizations. We're what's called a not-for-profit international voluntary consensus standards organization focused on developing standards for geospatial, sharing of geospatial data and services. We currently have 38 or so approved, adopted standards that have been implemented in the community. We have hundreds of product implementations, actually thousands and thousands of instances of implementations for a variety of our standards. In the case of KML, hundreds of millions of instances of implementations. We have broad user community implementation, and as was mentioned, we have alliances and collaboration activities with ISO and many other standards development organizations. This just gives you a mix of where our membership comes from North America, Europe, Asia Pacific, and South America. One of the fastest growing areas for membership right now is Asia Pacific. Last year, Europe became the region with the largest number of OGC member organizations. This is the structure of the OGC. Lots of boxes. But basically, we have 4 operational programs, and I'm going to touch on each of these programs as part of this presentation. We have the interoperability program, where we do test beds and pilots and interoperability experiments to look at capturing requirements and running rapid cycle engineering processes to test our standards or develop new standards that solve those interoperability requirements. We have the standards program, that's my area of responsibility, where we have committees that actually work on the standards, the development and the maintenance of those standards. We have a compliance and testing and evaluation program, which is a key aspect. You know, if you implement a standard, that's great, but if you don't implement it correctly, you don't have interoperability. And the idea of the compliance testing program is to test your implementation against a compliance test engine to make sure that you actually implemented the standard correctly. And finally, we have marketing and communications, where we deal with outreach, education, tutorials, press releases, articles, working with our members to make sure that information about the work of the OGC is properly communicated. So everything we do in the OGC is about partnerships. It's about technology synergies. It's about working with policies related to the use of OGC standards. And all these things have to work together in a consensus environment. It's an old slide. What was that? The OGC mission is to serve as the global forum, again this idea of global, for the collaboration of developers and users of geospatial data products and services in the advance and development of standards that enable interoperability. So what's the fundamental goal of interoperability? Quite often it's the best way to define it is when you don't have it. If you don't have interoperability, you do custom integration, which is extremely costly in terms of development and maintenance. You have high lifecycle maintenance costs. It's difficult to rapidly mobilize new capabilities. You have duplication of effort because everybody has to create these custom integration products. You have missed opportunities for improved decision making. And there are a lot of other things you run into when you don't have interoperability. This is an example of our member organizations. We have no way we can get all 469 logos up on one slide. But we have, as one of the earlier slides showed, we have very good representation from the private sector, commercial members, technology providers, many, many government organizations, universities, and research organizations and non-government organizations. We also have, I forget how many, 20-some formal alliance partnerships with other organizations that are involved in standards development. Everything from the very formal work of groups like ISO, the IEC, and the ITU, to much more relaxed relationships like we have with the IETF and the W3C. But again, it's all about coordinating and communicating and collaborating standards that enable geospatial interoperability. And we want to make sure as the OGC, with our focus on geospatial, that these other standards organizations, when they implement some sort of a location element or geospatial content, that it's consistent with and harmonized with the work of the OGC and ISO. Another area that I'm going to touch on in this talk is return on investment. And there are quite a few different studies that talk about return on investment. And I've got details and URLs later in the presentation. But it's been shown over and over again that there's a very large return on investment for implementing standards, and there's actually a return on investment for participating in standards development activities. So why open standards? You hear this all the time. You need open standards. Well, why open standards? First, you don't want a single organization or a party controlling the standard. You want a community consensus process where everybody shares in the decision, which gives you much better buy-in and a much better chance of the success of that standard. Open standards lower systems and lifecycle costs. They encourage market competition. You can choose products based on functionality. You can avoid lock-in to proprietary architecture. You can stimulate innovation beyond the standard. Companies can do this where they're seeking to differentiate themselves. What's an OGC standard? Well, an OGC standard, like any good standard, is a document established by consensus and approved by our membership. The standard provides rules, guidelines, and requirements that have to be satisfied when an individual or a group looks at the standard, they look at the requirements, they look at the rules, they implement their software to follow that standard, they implemented that standard, and they enhance the ability to have interoperability with other platforms. OGC standards are open standards. So what's an open standard? Freely and publicly available. All OGC standards are freely and publicly available. They're unencumbered by patents and any other intellectual property. All OGC standards are royalty free. We have yet to have anybody come in with a document and say we want royalties. As a matter of fact, the OGC culture is such that if some organization did come in with a candidate standard and said they wanted royalties, the rest of the members would probably say no way. It just doesn't fit our culture. It's the same as the W3C in that respect. Non-discriminatory, that means anybody can download our documents and implement them. Doesn't matter. There are no license fees. They are vendor neutral. That's a big issue for discussion constantly within the OGC to make sure that our standards don't favor any particular vendor. And there are some cases, when somebody brings in a standard from the outside, like Google did with KML, or Esri has recently done with the Geospatial Services API, there's a lot of discussion about, is that appropriate? Will that allow that vendor to get a market position, a competitive advantage? So we work very hard to make sure all of our standards stay vendor neutral, and that things change. They're data neutral. Everything's developed by consensus, and no single entity controls the standard in the OGC. They are a community document. Another key aspect of the work of the OGC is what we call balance of interest, which means that every member has an equal voice in the development of the standard. A university can have just as much input to a standard as a Lockheed Martin or a large government organization. And we have to abide by antitrust laws, which is why we have a lot of rules in our policies about how a standard is submitted, how it's developed, and how it's approved. But standards development is not easy. It requires collaboration on a global basis. For example, our hydrology domain working group has representatives from about 30 different countries working on various activities related to the sharing of water information. So it requires consensus by many organizations. It requires give and take. Nobody gets their way all the time. It requires a certified and repeatable process. Just as an example of OGC publicly available exposed services that are outside the firewall in Europe. This is 2010, and the services found in Europe, OGC services, was 6,500, of which 4666 were active. There are actually some new applications out there that have been evolving over the years that you can access that will give you a list of all the available, say, web map service instances in a particular region of the world. We currently have 716 compliant and implementing products registered on our OGC website. These are volunteer information. We know there are many, many more implementations out there that have never been registered. So here in the Korean community, if you do implement OGC standards, please go to this web page and register your products or your applications that implement OGC standards, because this is a freely publicly available page that anybody can go to find out who is implementing OGC standards. So it's free advertising. Another critical aspect of the work of the OGC that's evolved over the last few years, recognizing the fact that we are a global community, are our forum activities. And these forum activities are designed to allow a country or a region or a community to collaborate based on their time schedule, based on their language, based on their cultural requirements. So we have regional forums such as the newest one there is Australia and New Zealand. We have an Asia forum, a Europe forum, a Iberian and Latin American forum, Nordic forum, and a North America forum. The North America forum met 2 weeks ago. And how many people attended?
We had 200 registered for an event that they put together, and 160 actually attended, which is...
So we had 160 folks attend. They had exhibits, actually. We could go see OGC standards in action. They had a variety of papers presented and technical discussions. And the Nordic Forum met 2 weeks ago also for the first time, and they had 74 attendees from Scandinavia. And I guess it was a very vigorous discussion on a variety of issues and topics. So this provides a mechanism to feed information back into the OGC from a region. And it's the same for our national forums. There's a Korea forum, there's an India forum, and a France forum. And the France forum is probably the oldest of the national forums. They've been meeting twice a year for 3 years now. They've been very successful. And the Korea forum, I believe, meets on a regular basis also. Open standards and policy. It's great to develop a standard, but it never gets implemented. It never does anybody any good. And the OGC has failed if we don't have individuals or organizations implementing our standards. So it's really important to have policies. There's a lot of reasons for having policy statements regarding the use and implementation of standards, including OGC standards. It ensures governance, good practice around standards. It allows governments to harmonize their procurement rules. It avoids duplication, and enhances and supports collaboration, enables interoperability across organizations, saves costs. And vendors know what to expect when they submit bids to a procurement. So what we really want to do in terms of policy is help the policy decision makers address such issues as activity for public benefit. How do these standards enhance public benefit? How do you measure and record value of ROI? What is the business driver? How does it help internal efficiency? Does it increase customer satisfaction? Does the capability already exist? Or can you reuse, avoid duplication? This set of questions, along with the whole concept of value, is why the OGC a year ago instantiated a new group called the Business Value Domain Working Group, where we look at OGC standards and value to organizations, whether you're a technology developer or a technology user. And there are a lot of organizations that have implemented policies and stated policies related to the use of OGC standards, including the European Inspire Directive, the European Space Agency, GeoConnections Canada, which is the Canadian Geospatial Data Infrastructure Community, GEOS, national legislation in the Netherlands, for example, just approving City GML as a national standard, NATO, National Geospatial Intelligence, U.S. Federal Geographic Data Committee, and the USGS. And there are many other examples around the world about policy and the use of OGC standards. This is just an example from Canada. CGDI endorsed standards include OGC standards. And it's all about enhancing interoperability among all the stakeholders. The CGDI in Canada deals with the national to provincial to local governments. And they have defined an infrastructure, and they have a governance process that is, if you follow it, anybody can plug into the spatial data infrastructure for Canada. So if I want to stand up a new web map service, I just go to their website, look at the governance rules for the web map service, which includes what version and what parameters. If I implement following those rules, I can take my WMS instance and directly plug it into and make it accessible to the full national spatial data infrastructure. I mentioned Inspire. I think everybody is probably familiar with Inspire by now. It's the Pan-European Spatial Data Infrastructure. And they have a series of guidance rules, technical guidance rules that talk about how to use a variety of OGC ISO standards within the European community. And these are the OGC standards that are mentioned in various aspects of the legislation and technical guidance. So the OGC is driven by community needs. Everything we do is driven by requirements and needs as expressed by our members and by the broader community. One of my roles as CTO is to keep an eye on what's going on in the broader information technology world and to also bring those requirements into the OGC. So we're constantly reviewing and thinking about requirements and how our standards fit into the ever-changing information and communications technology environment. Interoperability and standards. Standards try to resolve issues such as all these wires up in the telephone pole, make it a lot easier to provide accessibility, to provide interoperability, to provide better access for citizens, better access by governments. I've already seen that slide, but I like the little picture there. I'd like to know how the baggage box got into the engine. That's an example of the square peg in the round hole. It doesn't work. When you don't have interoperability, that's what happens. You get a mess. These are just some more. I had one list of what happens if you don't have interoperability. This is another list, very specific to the geospatial community. You can't share your maps on the web. You know, our first web map, our first web services interface standard was Web Map Service, and it addressed a very simple problem that was stated by one of our members: is how do you share maps on the web into an HTML document on your screen? You can't deliver data to different systems. That's where Web Feature Service came from. We don't speak a common language to speak to about our data, geospatial data, or our services. That's where GML came in. You can't find data and pull it together from our automated sensors. That's where all the work and the sensor web enablement came from. We have security issues related to geospatial data exchange, so we have a domain working group that focuses on security, authentication, and authorization. That's the repeat. There's my repeated slide. Another thing about the OGC process, and it gets back to other things I've said about balance of interest, global collaboration. There are a lot of things we do in terms of engaging the public. We're not closed. Yes, we have members and we work on standards in a standards working group, which is closed to members only. But we also engage the public as much as we can. So we have requests for information that go out. Every time we have a new test bed, there's a call for participation that's globally announced. Anybody can bid. We get requests for comments. Anytime a standard is ready for at a certain stage in the process, we send it out for public comments. So anybody can provide input. We have public change request submissions. So anybody can implement our standards. Anybody can submit issues, problems, and suggested changes. We have a public forum. We have OGC Network. These are all public. We have public email lists. And some of our domain working groups are public. We try to engage the general community as much as possible. As I mentioned, we have many other alliance partnerships that we deal with, and these are incredibly important to the long-term viability and the work of the OGC. We believe in a very respectful cooperation between standards organizations where we respect the autonomy, integrity of the processes, and intellectual property rules of these other standards organizations, which for me makes life interesting because I have to understand the policies and procedures of 6 or 7 different standards organizations, and they're all different, so I get confused. The whole idea then is to have better, consistent standards that meet global community needs. So for example, in the OGC, we have the geography markup language, which is based on a variety of ISO standards developed in TC211, geomatics. And about 6 years ago, the Internet Engineering Task Force, the group that deals with standards for the Internet, said we want a location object. And somehow I found out that they were talking about defining a location object for use in Internet standards. So I jumped in, and we had a long dialogue, and after about 2 years, they decided to develop a GML, geography markup language, encoding for describing the location object for the use in Internet standards. That application schema of GML is now referenced by about a dozen different Internet standards, including some very widely used Internet standards. So that's an example of how we can collaborate with other standards organizations to ensure the consistent expression of location. So why participate in a standards organization? Organizations are generally unaware of the strategic significance of standards. This is especially true as you get up to the executive level in an organization. It doesn't matter if it's a private company or a government organization. Managers simply do not understand, in many cases, the strategic significance of using standards. Corporate decision makers seem hardly aware of the benefits of standards. This lack of knowledge on the part of decision makers and organizations means that strategic potential of standards is not fully appreciated. From a member perspective, what that means is the folks working on standards tend to be technical in nature somewhere in their organization, and they have to go every year back to their organization and convince management to fund membership in the OGC. And it's unfortunate the high-level managers quite often don't understand the significance of the standardization process and what it can mean to the bottom line or revenue generation potential of their organization. So standards are a business imperative. This was a study done in 2003. It's just as germane today, just as important today as it was back in 2003. While tactical thinking does indeed predominate in today's conservative spending climate, the lack of enterprise integration has created such a costly infrastructure that it represents an immediate and pressing mandate for standards. Compliance with standards in software development is not simply a strategic direction, but a business imperative. And there are companies and government organizations that really understand this. And they tend to be leaders in the adoption of standards in general, not just OGC standards. There are a lot of competitive advantages through standards. For folks developing technology products, having influence in the content of standards is an important factor in gaining competitive advantage. Just because it's a consensus process doesn't mean you can't have significant input. And if you're good at it, which some of our members are very good at it, they can push a standard in a direction that actually helps them. And they have knowledge about what's in the standard so they can actually start developing product to meet the rules of the standard and be ready to go on market as soon as that standard is approved. And that's how they can gain an edge over non-participating companies in terms of insider knowledge. The next set of slides I've gotten from the German DIN study on the value of standards, so I'm not making this up. This is from a very broad survey of industry and government in Germany in terms of the value of standards to the German government and the German technology community. For consumers, users and consumers are able to express requirements. That's a big, huge thing in the OGC. And to express use cases in a non-procurement neutral form directly impacting the development of standards. And it also gives technology consumers insider knowledge of the standards so they can drive better procurement language and policy that benefits their organization. Standards lead to lower transaction costs in the economy as a whole, as well as savings for individual organizations. Transaction costs drop considerably as a result of standards, since they make information available and accessible to all interested parties. They have a positive effect on the buying power of organizations. They help organizations avoid dependence on a single supplier. Organizations have increased confidence in the quality and reliability of suppliers who use standards. Organizations can use standards to broaden their potential markets. These are all well-documented aspects of implementing standards. It allows organizations to form strategic alliances. What we find in the OGC in terms of the process is many of our members network on a very long-term, consistent basis. They develop strategic alliances that help them do better business, provide better service to their customers. And it actually shows that standardization enhances the cooperation with competing organizations. So in the OGC, you see all the big GIS companies working together collaboratively on OGC standards, even though they compete very, very hard in the marketplace. Standards in research and development. Organizations can reduce the economic risk of their R&D activities by participating in standardization. They can also lower their R&D costs because they don't have to worry about interoperability. They don't have to worry about writing custom software to glue pieces of services and software and data together. They can also influence the content of standards to their advantage, which makes their economic risk lower. The expense of R&D is reduced when participants in standards work make their results generally available, as the research does not need to be duplicated. Inside the OGC, there's a tremendous amount of research that's done. And eventually, all of this research becomes public. And we've had members say that the value to them in the membership is simply to have access to that ongoing research. We have high-level members that never come to an OGC meeting, and yet, when you ask them, well, why do you keep paying $12,000 a year or whatever they're paying US? And they say, because I have access to all of this research and development activity that would cost me hundreds of thousands of dollars to do internally. I get access to it for $12,000 a year. Huge return on investment. And a big myth out there is that standards inhibit innovation. That's patently untrue. Fact check. Standards serve as a knowledge base and catalyst for innovation. Again, it's the German study, but there are many other studies that have shown the same thing. Norms and standards are a source of knowledge for research and development, for they reflect the current state of technology as a result of participation by numerous experts in the relevant fields. This goes back to my statement that the work in the OGC is not boring. We solve and address and talk about very sophisticated, complex technical issues related to geospatial data. And we have experts from around the world, so it gets to be a very exciting dialogue at times. So, what are the most commonly used OGC standards for spatial data infrastructures? Most of the ones that are most commonly used are the web service standards, along with simple features. There's something called the Spatial Data Infrastructure Cookbook, and a number of us just finished working on a revision to Chapter 10 that talks about the OGC ISO standards baseline for spatial data infrastructures and for the global spatial data infrastructure. It'll be posted here in the next month or so. But in that chapter, these are the standards that are addressed. And these are OGC and ISO standards. Metadata. Web map service, web feature service, web coverage service, web app context, style descriptor, catalog, markup language, KML, and web processing service. These are the ones that are most commonly implemented on a global basis in spatial data infrastructures. Obviously, other OGC standards are implemented based on regional and local requirements. This is where OGC standards fit in the stack in terms of spatial data infrastructures. We're up at the application level. Obviously, there's a bunch of stuff underneath, like the internet, the web, mobile platform technologies, and so on. This just shows where all the pieces fit together in the web services framework. We actually do have a framework. Don't talk about it much. So just quickly going through these different standards. What are they? Well, one of the ones that's widely used in spatial data infrastructures, because you have to be able to discover data, is catalog. And it's just a database of information about resources, data and services available to the group. Typically, the stores descriptive information about the resource. It does not store information, store the information resource itself. Such descriptions are known as metadata. So a lot of the spatial data infrastructure catalogs that have been deployed use ISO 19115 or a profile of ISO 19115 for geospatial metadata. So it's all about a user being able to sit at a terminal and discover data. And for content providers to publish information about that data so that users can actually find and utilize that data. Current version of the catalog is 2.12, and there are multiple profiles based on different technologies. The most widely deployed version of the catalog, as far as I know, is the ISO 19119 metadata profile. That's pretty much consistent, say, with the Inspire requirements in Europe. Web Map Service. As I mentioned, that was our first OGC Web Services standard. And it's designed to solve the simple problem of I'm in a client application. How can I access multiple GIS data repositories and get a map image on the screen where everything is geo-registered correctly? This does not return data, it returns geo-registered images. This is also the most widely implemented OGC Web Map Service. As near as we can tell, there are 12 to 15,000 instances around the world giving access to over 1 million layers of information. Yeah.
1119 is services. You want 191139, whatever.
Oh, yeah. Thank you, John. I have to fix that slide before we post it for everybody. So this is just some of the technical information related to the OGC Web Map Service. It allows you to express a coordinate reference system, your area of interest, the box surrounding where you want the data, how you want the image returned, height and width. It also provides the ability to say what data do you have accessible. It allows you to specify symbolization through style layer descriptor, and you can specify a return format. So give me the image back, say, as a GIF or a JPEG. And here's some examples from different communities of Web Map Service. Web Map Context. It's a container for sharing the state of the user's view. So you go out and you do some work, and you generate a really nice image on the screen, and you want to share it with somebody. Or you want to come back in a week and be able to look at the same image after you've done a lot of work. This is what Web Map Context lets you do. It lets you specify how you generated a Web Map Service image, store that information as an XML encoding, and share it with other people. There's a lot of work going on in the OGC right now. We have a whole standards working group working on OGC Web Services context. So it's not going to be just for web mapping, but all of our OGC Web Services. And they're very far along in that work right now. Style layer descriptor. This is how you control the presentation style of a map trail. So how do you specify the rules to display the maps that are coming from a web map service or a web feature service? And this is what style layer descriptor is for. It allows fine-grained control of symbolization on a layer-by-layer basis. It's rule-based, uses XML, and allows expression of rules with the trail, which is really nice because you have a map data that may have to be displayed on many, many different devices, not just the desktop, but perhaps my mobile phone. You don't want to change the data, all you want to do is change the presentation style, so you can have different style layer descriptor rule sets for the same data for different devices or different applications. Web feature service. A web map service gives you a picture. A lot of power there. However, quite often you need the data. You need the vector data. Web feature service is a service that provides transactions on and access to geographic features in a manner independent of the underlying data store. So that lets me, as a user, I can do it's called a get feature request to multiple different spatial databases, say one in Oracle, one in Esri, one in, pick your favorite geospatial vendor, one in Bentley, one in Autodesk. And you can get a list of the data available, and then you can say, well, give me all the features from these databases for roads. And from these databases, give me all the features in my area of interest for vegetation. And download them to my device. So it could be down to your desktop, down to your cell phone. And what's interesting is Web Feature Service supports transaction processing. So you can not only download the information, if you make edits to it, you can upload it and use the transaction aspects of Web Feature Service to transact those changes to multiple geospatial databases. Here's an example. There are many, many examples of Web Feature Service. This is for the USDA Forest Service Fire Data Web Service application, which I found out about because we had many, many wildfires in Colorado this summer where I live. It's the town of Fort Collins that I live in. We had very heavy smoke for weeks because of a huge wildfire a few miles outside of the city. And some other Web Feature Service examples with their URLs. Web Coverage Service defines a standard interface and operations that enable interoperable access to coverages. Typically refers to such things as satellite images, digital area photos, elevation data, and other phenomena represented by values at each measurable point. Sometimes called the surface covering tessellation. To be used to query against multiple coverage repositories, such as imagery archives, and have the selected data returned to you in one of several formats, such as GeoTIFF. So like Web Feature Services for your vector feature data or other types of feature data, Web Coverage Service can be used to return express query constraints and then return the coverages in some standard format. And again, there are many examples of Web Coverage Service. Widely used in the satellite community, for example. A lot of the commercial providers also support Web Coverage Service. SensorWeb. You're going to hear a lot more about the SensorWeb standards later today. This work started in 2000, 2001. It was about how do you describe, task, and access observations from web accessible or network accessible sensors. We call that sensor web enablement. So it's all about enabling discovery and tasking of sensor assets and to access and apply sensor observations for enhanced situational awareness. There's a suite of OGC standards that represent what we call the SWE baseline. Sensor model language for describing the sensor and the processes associated with the sensor. Sensor planning service for tasking the sensor. Sensor observation service for getting measurements and observations from the sensor. PUC, which is a protocol for very low access to initially ocean sensor systems. And there are complementary standards that go along with this also. And there's a lot of work going on in this area currently. Got these in here twice. Excuse me here. So here's the SWE architecture. And you can use the standards, the SWE standards, either individually, as a group, or with other OGC standards. And here's an example of sensor web enablement with OGC test beds. In this case, dealing with chemical, biological, radiological, and nuclear sensors, and how a client gets real-time information from any of these sensor types, regardless of who manufactures the sensor, as long as they're network accessible and described using SensorML and access to using sensor observation service, information would be utilized and integrated with other sources of information. Some examples of sensor observation service. Works with UAVs, like this little thing up in the one side here is a little helicopter that's got a digital camera on that's actually tasked using sensor planning service, and the images from the helicopter are rectified and accessed using Web Coverage Service. Web Processing Service designed to standardize the way that geospatial calculations such as polygon overlay are made available to the internet. WPS can describe any calculation, including all of its inputs and outputs, and trigger its execution as a web service. This particular standard started 4 or 5 years ago and quietly went through the OGC process and was quietly deployed and quietly implemented. And now there are hundreds of implementations of web processing service out there because you can wrap existing legacy systems with web processing service and plug it into a web services architecture. And groups have done things like taken GRASS, which is an open source image processing software suite, and wrapped every single one of their API calls in a web processing service. So everything, they made GRASS suddenly web accessible by wrapping their API in web processing service. These are just some examples of how you can use web processing service in a variety of different ways. In this case, it's just displaying feature data with different symbols. Geography markup language. GML is an application of XML. And it lets you encode and describe digital feature data. What it does is it lets you specify schemas that specify XML encodings of geographic features, their geometry, their attributes. A lot more. Current version is GML 3.3. And 3.3 is really interesting because they've started to unbundle GML into smaller units. The evolution of GML, we're going to get a lot more from David Burgraff on GML, so I won't say too much more. But GML is about representing features for multiple communities. And the best way to use GML is to get together as a community and define an information model first, and then encode it as GML. Now, a lot of the work by the OGC community is about defining information models, say for sharing weather data or aeronautical information, or water information, water observation information. They define the information or content model first, so they describe it as UML, and then encode it as GML. Related to GML, but not competing with GML, is KML. Initially, there was a lot of misunderstanding about the relationship between KML and GML. KML is for geographic visualization. It's not for content modeling or sharing geographic data. Some people try to use it for that, and it's not designed for it. And it lets you display place marks, images, polygons, do all kinds of really cool things in terms of visualization in either mapping or primarily Earth browser systems. And it's not a geographical modeling language. Interestingly enough, however, all the geometry elements in KML map back to GML 2.1, in fact, the reverse latitude and longitude. Everything else is pretty consistent. And once people discovered that KML was for visualization and GML is for modeling and content sharing, lots of tools became available to stream GML to KML to an Earth browser system, and they work very nicely. Now, this is an example of how you develop a content model and then express it as GML. CityGML started as a project in Germany 6 or 7 years ago, and they wanted to share 3D city models. So they developed a whole information model that was harmonized with building information models. And they said, let's encode it as GML. And CityGML then was brought into the OGC by the German community and went through the process and is now version 2.0. This is especially important with respect to cost-effective, sustainable maintenance of 3D urban models. It was driven by policies in Germany related to livability and sustainability. They needed to share, all the different cities needed to share 3D information and feed them into various models that were used to, say, do noise reduction or enhance environmental aspects or improve the use of solar or wind power. It had a lot of different applications. And these are just some of the examples of things that are expressed in CityGML. I don't know about the lunar landing module up there. So then, again, all these standards do not exist in isolation. I mean, you can implement just a web map service if you wish to expose some of your data to the world and to share it with your constituents. But typically what's happening is many different OGC standards are used as parts of workflows. I mean, when you think about how a government works, there are always workflows. How do you get a permit to put up a building? How do you get a permit to build a swimming pool? How do you do an environmental impact assessment? These are all workflows that go across many, many different departments, require input from many different individuals. So you have workflows. And these workflows then say, well, we have many different services we need and many different data sources that we have access to. So you end up using many different standards. Because each standard solves a specific interoperability requirement. And you're looking at the complete integration of the flow of data through those workflows. So for example, just to get to that point, when you're delivering spatial web services on behalf of 20 government agencies to more than 1,000 organizations, each running their own spatial systems with their own policies and governance and technologies, you need standards. Using the internationally recognized OGC and ISO standards for both the architecture and web services has been essential to our success. Kylie Armstrong, Western Australia, Landgate. What time is it, John?
Can I ask her mine?
Yeah, we're doing fine. This is the next section. I guess I should stop. Any questions at this point? Yeah.
Could you please elaborate in the CityGML level of details? They call it LOD 1 to 4.
Yeah, all four.
I'll talk more about that too.
Yeah, there's going to be more detail on that when David talks. You can actually, there's some really interesting projects where you're using high-level LiDAR, very fine resolution radar, LiDAR, translated into CityGML. So you can actually see things like bullet holes in buildings. So that's level 4, I guess. Anyway, the next section is on recent standards work in the OGC. And this gets back to the whole idea that standards work does and can be extremely innovative and highly agile. One of the complaints about standards work is that we're slow and it's stodgy and bound up in process. Well, actually, standards organizations can be incredibly agile, especially groups like the OGC. If you come in with a well-formed idea and you get the resources behind it to do the work, things can go very quickly in the OGC. It can be very responsive to community needs. It doesn't take us years to get something through. Sometimes it does. But we've had standards go through in as short a time as 9 months. So we can be very responsive. This is a very new activity that came out of requirements from initially, I believe, the Army Corps of Engineers. And their problem was, in an emergency situation, how do I get geospatial content out to a device that's going to be disconnected from my home computer system and may not have internet access out in the field. And then when I take it out in the field, and I'm using that information and I annotate it and I change it, how do I go about getting those data back to the centralized databases that I'm accessing? So we have this concept called geopackage management. And this slide's from Compusol, who's been heavily involved in what we call the Geopackage Initiative. What Geopackage is a self-describing payload of geospatial data. So the workflow might be retrieve data from your data archives, and you'll get all the street signs and roads and building footprints, and package that up into this payload, and put it off into your cell phone or your iPad or your other mobile tablet. And then you can go offline. This is a critical requirement in not just emergency services, because quite often, you go into an area after a typhoon, there's no infrastructure. The cell towers are all gone. You have no connectivity. Another case is military personnel out in the field. They need geospatial data, and quite often they have no access to the internet. So there are many use cases like that. So they take it out in the field, and they've got the geopackage data, and they can utilize it and do things with it. and they can look at maps, and they're all, so that means everybody's looking at the same data out in the field, which is great for situational awareness. So that's a very recent OGC activity. And so you can run it offline, you can run it online, and if you integrate it with another ongoing OGC project called geosynchronization, any edits you make out in the field can then be transacted into all of the repositories to make sure all of them are updated based on field data from the mobile workforce out there, whether it's an emergency responder or a warfighter or whomever, utilities guy collecting information. You can geotransact that all to the various geospatial databases so everybody has access to the same data. A recent project came out of the Asian community. SMS defines short message system. It's an encoding for lightweight text information. We all use SMS on our phones, and we use Skype chat and things. We're using SMS. But it was never location enabled. So the very simple question they had is, how do you location enable an SMS message? A group in Taiwan came up with lightweight exchange protocol they called OpenGeoSMS. When it first came into the OGC, it wasn't aligned with anything. It went into a standards working group, quickly got aligned with other OGC standards, as well as the work of the Internet Engineering Task Force, the ITF. And they came out with a standard for encoding location that's compatible with other OGC standards, but for using an SMS environment, which is really nice. And it's already implemented widely in a variety of environments, not just in Taiwan, but Ushahidi and Sahana, which are collaboration platforms for humanitarian efforts and emergency disaster response. And it's designed to work with any device that supports SMS. It's pretty cool. Another area that we're in is augmented reality, something called ARMA 2.0. Augmented reality is about enhancing the image on the screen with other types of information that provide additional knowledge to, in this case, the consumer. Augmented reality is just not a consumer application, it's also an enterprise application. And many of the deployed examples, sophisticated examples of augmented reality are in businesses and governments, not to mobile devices. But our goal is actually ready for public comment. It's going to be reviewed by the OGC Architecture Board at the meetings here in Seoul, and hopefully goes to public comment. Another area of big activity is 3D in the OGC. This is coordinated through the group called the 3D Information Management Domain Working Group, 3DIM. The group got together and did a really fantastic job with the 3D portrayal interoperability experiment. It contains technical details on processing 3D information in OGC services as a set of best practices on how to portray large data sets for urban planning scenarios, taking into account different architectures and capabilities for 3D graphics. There's a public engineering report out there that talks about all the lessons learned and how to use a variety of OGC standards, including 2 candidate standards. There are hundreds of hours of research of this project. This is where it gets back to my saying that there's huge value in just watching and learning and participating in the research that happens inside the OGC in terms of the development of our standards. There's another interoperability project that recently finished that is also extremely well done, which is a hydrology surface water information modeling interoperability experiment that tested something called water and mouth, which is an OGC standard. Another area, the one near and dear to the hearts of the Korean community, is indoor location and navigation. And it's all about how do you integrate, first how do you describe an indoor environment? How do you model an indoor environment? How do you share information about an indoor environment? Not just the floor plans, but all the information related to the indoor environment. And how do you use it in a set of applications? And how do you have seamless movement between the outdoor environment and the indoor environment? Because they are different and they're described differently. people think about them differently. So there's a lot of work going on inside the OGC, and I know there's some series of meetings here, the OGC technical meetings this week related to indoor GML, GIS BIM CAD integration, and a variety of different things related to this particular project area. And it's not just the OGC. A lot of other organizations are looking at the same problem from different perspectives. So we coordinate. Social networking. We all social network in some form or another, using online things like Twitter and Facebook and LinkedIn and on and on and on. Flickr, Picasa. There are dozens of these applications out there. A lot of them are location enabled. So how do you go about gathering all that information that's crowdsourced and it's location enabled and do analytics on it? How do you enhance your data? How do you generate new data? How do you assure quality of the crowdsourced data? And these are just some of the groups out there in the emergency and humanitarian communities that collect crowdsourced information. Companies are interested in this because they love to track, say, Twitter, location-enabled Twitter feeds, and look at, from a marketing perspective, ways to better penetrate different crowds for economic advantage. There are many different uses. So there's a new project called Cobweb, which is a European Union-funded 7th Framework project, looking at crowdsourced geographic or volunteered information and how you can integrate it into existing spatial data infrastructures. You're using the UN platform as the spatial data infrastructure. It's all open source. And how do you do quality assurance and accuracy management? So that's what they're studying. The Internet of Things. There's a new OGC standards working group looking at OGC sensor web standards and the Internet of Things. This just gets down to the fact that everything's going to have a location. You're going to be trackable and traceable. It goes to the idea that for every human being on Earth, according to a recent study, there is something like 10,000 sensors for every human being on Earth. That's a lot of sensors. We're looking at potentially 1 trillion sensors by 2020. Many of them will be accessible online. What do you do with it? How do you access it? How do you describe it? How do you do analytics? Talk about a big data problem. There's a big data problem. The value of that information is potentially incredible. So that's why we're getting into it in a big way. In both those cases, the Internet of Things and crowdsourcing is about leveraging citizen contributions. There's huge value there. And there actually was a study done in Australia that showed they really lost huge value in an emergency response situation because they did not have access to crowdsourced information. The government policies did not allow the proper integration and use of crowdsourced information. And they were at a huge disadvantage in the floods of 3 years ago? 3 years ago, 2010. And it also gets into user applications such as environmental monitoring. If I walk around with my cellular telephone, which has, most of the modern smartphones have 6 or 7 sensors on board, you can do a lot of measurement, a lot of observations. How do you integrate all that in as crowdsourced information for environmental monitoring? Which is the use case, those are the use cases driving Cobweb in Europe. This is another example using OGC standards for integration and finding where do I charge my electric car. Something called Belay. And it came out of something, the Austrian Research Promotion Agency. It's a pretty cool application. This was presented at the OGC meetings a couple of meetings ago. All part of e-mobility, which I think is one of the key use cases for the Korean ubiquitous city, is e-mobility. Now I'm going to get into some of the collaboration examples. Those are examples of innovative new standards work areas of the OGC that builds on all the work we've done for the last 15 years. Aviation. Aviation is a domain the OGC members have gotten much more heavily involved in over the last 3 or 4 years. You going to talk about that too? Huh? For you going to talk about AXM or anything like that?
A little bit, yeah.
This is an area GML is heavily invested in. But it's about developing and testing standards-based service-oriented architectures to support the provision of valuable aeronautical and weather information directly to flight decks on airplanes. And it's a collaboration between the European community and the U.S. Federal Aviation community and many of the vendors that support Eurocontrol and FAA. And there are some airlines involved. And it's kind of interesting to me because what this means is the new generation planes, the cockpits are fully digital. They can get real-time alerts, and they can get digital information such as maps, runway maps, status maps, special access area maps, and so on and so forth, right to the cockpit. And they're going to be using OGC standards. So I'm sitting on the new generation plane flying across the Pacific thinking, oh God, they're using OGC standards and my life is in the hands of OGC standards. But, it's interesting thought. And as a result of this collaboration, we've been doing a number of test beds in the OGC related to aviation to support the vision for aeronautical information management. Because they have many different interconnected systems with many actors and many users. They need for real-time information used in flight planning, navigation, and rerouting. And they need the right information at the right time, just like emergency responders. And it has to go to the right user. So they have end-to-end management of information as a critical aspect. This gets back to workflows and sharing information across multiple organizations. So in the OGC environment and these test beds, you get many different member organizations working together to solve specific interoperability problems. In this case, it was one specific alerting case, and they had 4 different member organizations working together. 8, 9 different member organizations all working together, providing different services and different data sources to solve a particular interoperability problem. So again, in the OGC, regardless if it's developing a standard or defining a standard or testing standards against requirements, it's a collaborative community process. It's just not one company or one organization doing something. So that's aviation, hydrology. I've mentioned hydrology before. The hydrology domain working group provides a venue and mechanism for seeking technical and institutional solutions to describing and exchanging data related to water. In some countries, water is incredibly critical in terms of being, especially fresh water, as being a resource. So the ability to collaborate on a global, regional and global basis in terms of describing and sharing information about water assets, modeling water assets, planning for distribution and utilization are critical in terms of policy. So I mentioned the hydrology interoperability experiment. It was all about advancing something called Water ML 2.0, which is for sharing in situ water observation information and making sure that it worked with other OGC standards and workflows. One of the regions or countries where water is critical is Australia. The Bureau, the Australian Water Resources Information System, is being built in Australia to share and deliver high-quality water information to all Australians, not just share between governments, but also citizen interactions. And buried down in there is the broad use of OGC standards for access and sharing of water-related information to the Australian community. And there's also this concept, it's just not national, regional, but also global. So I mentioned way earlier in my presentation, water is a global resource. So there's a whole group out there working on a world water catalog. Where are all the in-situ sensors in the world related to water? How do I access them? How do I get the observations in a standardized way? How do I share it? How do I apply it? And again, they're using a whole variety of OGC and ISO standards to implement this particular catalog. Ecology and biodiversity. There's a project called Afro Maison. Aims to propose concrete strategies for integrated natural resources management in Africa in order to adapt to the consequences of climate change. It's 15 partners, 6 European Union, 6 African, and 3 international. It's funded again out of the European Southern Framework. But they're looking at mapping and providing information on ecosystems, multifunctional landscapes, defining areas of vulnerability, modeling, and providing government and citizen access to this information. There's a variety of expected impacts when this is completed in 2 to 3 years. And again, it's all about enhancing, in this case, sustainability of the environment and biodiverse ecosystems. Defense and intelligence. This is another area. The OGC has had a long series of activities and standards development activities. Many of our requirements come out of the defense and intelligence communities initially. Big areas, command and control, for example. Real-time access integration and fusion of static and real-time assets to support the warfighter. When you think about this, it's actually not just military applications, but it's command and control, situational awareness, intelligence and reconnaissance for responding to a wildfire, responding to a fire in a building in the city, responding to a water main break in your city. The same standards, the same workflows are critical. The real-time aspects are identical. Hurricanes, typhoons, earthquakes, all have the same set of requirements. This is just an example of something called Common Shield, which is a military exercise. Where they used probably 15 different OGC standards to tie information in from maps, from video streams, from assets in the field, to satellites, to UAVs, all bringing it together to provide information out to all of the assets, air, sea, and ground. And in all these environments, we're talking about multi-source, multi-user, distributed. And it's the integration of static and real-time information assets combined into a variety of fusion workflows. So you're getting data from sensors on the ground, sensors in the air, mobile workforce out in the field with their smartphones. All this stuff has to be accessed. And this is a very typical use case that you see over and over and over again. It doesn't matter which domain you're working in. If you're a pilot in an airplane, real-time information as I need it. An emergency first responder to an emergency response. The utilities worker going out in the field to replace a transformer that was hit with lightning. It's all the same in terms of the use case definition. It's just the actors are different. So that's just summarizing what I said. And again, there are many examples. In this case, this is an application from NGA. Emergency and disaster management. This is another OGC domain working group. Typically in our test beds, the majority of the information and use cases we get is for emergency and disaster management because it has very well-defined end-to-end workflows. So it's a forum for united communities of users, including government agencies, industry, research organizations, non-governmental organizations, and others, to promote a dialogue, collaboration, and innovation concerning interoperability for emergency and disaster management. So again, just like the command and control systems, you have real-time data collection technologies, you have your static databases, Those get fed into models of data fusion and mediation environments that then allow deployed applications to the end user. And again, we have many different scenarios. This is from Taiwan, debris flow, which we're now getting in Colorado thanks to the wildfires. So this is just one example of what I was talking about. Typhoons and earthquakes trigger landslides and flooding on a frequent basis in Taiwan. OGC services are used with an array of spatial data existing and sensors to provide situational awareness for forecasting, detecting, alerting, and responding to debris flow situations. It allows rapid deployment of a network of debris flow sensors and distributed services performing sensor data analysis and processing. This was deployed because 3 or 4 years ago there was a major debris flow in which there were a large number of deaths, and the government said we have to prevent this as best we can. So they put a whole new system in place that integrates real-time sensors with satellite feeds with existing in situ information, say steepness, gradient of slope, stream flows, things like that. It feeds into a model. When certain thresholds are recognized by the model, alerts go out to the community. And the alerts go out to mobile devices, television, radio. So far, it's worked extremely well, and we've done a great job in terms of preventing additional fatalities. And what they've discovered through this is the success of our programs to monitor, detect, and warn and respond to emergencies and natural disasters in Taiwan depends heavily on OGC standards. We use OGC web services and sensor web enablement standards to rapidly mobilize, monitor, forecast, and deploy warning networks to implement a diversity of sensor assets as part of these systems. This saves time, money, and lives. It's from the director of the GIS Research Center from University. And it's not just there, but Inspire has a whole infrastructure also related to emergency and disaster management. Again, it's part of the 7th Framework Program. It's related to Inspire. And it's the same concept, integration of real-time information with existing information assets to feed into modeling environments to alert the citizens when there's an issue that they need to be aware of. It could be a chemical spill, could be a weather event, could be any other event where citizens need to move and be evacuated to make sure that their lives are saved. Another example in emergency and disaster management are tsunami warning systems. There's one that was developed jointly between Germany and Indonesia. It's been deployed, same concept. OGC standards for oceans, marine, and oil spill monitoring. There's something called CDataNet out there. It's an efficient distributed marine data management infrastructure to manage the large and diverse sets of data. For, again, in situ and remote observations of the seas. And it's all about providing a pan-European network of online integrated databases related to information about the oceans and all the sensors that are accessible for monitoring the seas and oceans. Another one's called Clean Sea Net. And it's about the detection of oil slicks and oil spills using satellite surveillance. And it's about there's potential oil spills. Coast Guard goes out, checks, and if the ship is in violation, they detain the ship and clean the spill. This is a deployed system, and it's built on a variety of OGC standards. And at the national level, for example, the last one was regional. The national level for oceans is NOAA as the Integrated Oceans Observing System, which provides access to thousands of sensors doing ocean observations, again, all enabled through OGC standards. 3D information management in the built environment. We touched on this already. And it's about the interoperation of data across the architectural engineering, construction, CAD, and GIS domains. Sharing 3D information models, 3D visualization, location services, indoor, outdoor navigation, are all related to the 3D built environment. And I've touched on all of these already. And then again, we have a workflow. And again, we have situational awareness requirements. And the building information lifecycle uses geospatial data all the way through it. And we in the OGC, the members, are concerned about the flow of geospatial information through that entire lifecycle. This goes back to the slide I had at the beginning about the cost of the U.S. economy of not being able to share geospatial information through the entire life cycle of the building. And I already mentioned indoor spaces and locations. A lot of the work here is related to semantics. When you describe a building, when you describe the 3D environment for the urban situation, you have to worry about the semantics. And these are all part of developing the models and how they're encoded in GML. And I mentioned some of the examples of using CDGML. This is Seoul Air Energy Reduction Potential Analysis using 3D urban models shared as CDGML. And more recently, they've gotten into utility networks. This is another area the OGC membership has just decided is really important. And that's utilities and energy distribution. The problems are pretty much the same, whether it's an electric utility or an oil pipeline. You got to model it, you got to encode it, you got to use it. But they had a whole variety of cases for underground utilities, and they came up with an extension package to CDGML for modeling and expressing underground utilities. And as I mentioned, we have a new energy and utilities domain working group to look at requirements for that community and how OGC standards can be used. So, summary and conclusion. You do get good return on investment, not just as an end user, but as a technology provider. OGC is about interoperability. We tend to focus on technical interoperability. But more recently, we've also gotten into issues related to legal interoperability. We have a spatial legal group out of the board of directors that's concerned about spatial law and policy discussions, things like privacy, the legality of crowdsourced information, the legal implications of using crowdsourced information. There's also cultural interoperability. When we deal with developing standards, right now we have membership from 37 or 38 different countries. So we're dealing with cultural interoperability in the development of our standards. We're also dealing with organizational interoperability. Government organizations, technology providers, universities around the world represent different organizational structures, different requirements. So we're dealing with organizational interoperability. So while we're primarily technical in the development of our standards, we're very much driven by these other types of interoperability issues also. And it's fun to think about the use of OGC standards is not just the traditional, we think of GIS applications. Here's the University of San Diego Supercomputer Center has been looking at the use of OGC standards, GIS in the brain. It's a 3D environment. It's topologically structured, your brain. It's a network. So a lot of the work we're doing in the OGC, and what they're doing here actually is using web coverage service, sensor observation service, and a few other OGC standards. When they scan the brain, every image is described using sensor ML. I should say the instrument is described using sensor ML, the MRI machine. The images are captured using sensor observation service and shared using web coverage service. And it's all brain. And it's all part of the health modernization program in the United States, where they can share everything in digital form across the internet. So they capture it in digital form, then you go to see your neurologist, and he has access to the same information using OGC standards. Now, I'm not saying this is deployed nationwide, but this was a test bed activity to see that they could actually use OGC standards for the brain. It works.
Is it indoor and outdoor?
Is it indoor or outdoor? Good question.
We're trying to use a similar thing in soccer game analysis.
Soccer game analysis? So with that, thank you for your attention. That finishes the first presentation. Are we on time? 15 minutes early. So you didn't think I'd get through all my slides, did you, Jimmy?
Well, I didn't know you could do it in the course.
Yeah, I didn't. Somehow this presentation is actually missing some slides because I have slides on operability program and compliance testing. So anyway, any questions?